who's doing a product briefing talk here about something that is actually free. As far as how we make up for the fact that we don't charge anything for it, the answer is, of course, with lots of volume. What Rep Manager does is it makes a couple of replication tasks easier, starting with PostgreSQL 9.0 and trying to continue to add more features for later versions as well. The idea that Rep Manager targets is that you've got a cluster that's set up using PostgreSQL 9's streaming replication, and you've got some number of standby nodes that you want to connect up to it. If you just got one, it's a little bit easier to deal with a lot of replication problems, but Rep Manager came out of requests from customers that we had that said, well, yeah, it's easy enough to set up one node, but we want to set up 6. We want to have one in New York and one in London and one in Paris, all these major areas that they had offices at. And just dealing with all those things spread all over the place, you get into questions like, well, who's got the latest copy of the data? If I have to do a failover, what city do I go to? Those are the sort of things that Rep Manager tries to make easier than just what you get in Postgres alone. The idea behind Rep Manager is that you have a couple of fairly simple operations that you can execute on it that are aimed to be Rep Manager followed by the command, followed by something that you operate on. It's a similar sort of syntax for the command line tool that you see for tools like get have that same type of structure to them. The main thing that you start out with is registering a master, and then you have a couple of different operations you can do on the standbys depending upon what state they're in and what state you want them to be in. So the idea is each one of these does a state transition for a standby to get it to do to get it to serve in another role. Standby clone is the one that you're going to run first. It does everything that you need to go and add another standby to the system and get Rep Manager the structure that includes get it installed on the system and go from there. You just do the same thing again. You want to add more nodes, you just keep adding them and telling them where it is that you want them to go. It really is this easy. This is actually pasted from a working example where I set up Rep Manager on something. You just run it and say, clone, give it where the node is at. There's one simple configuration file that just lists what the nodes are and other stuff like that. And you start a daemon in the background that helps with some of the monitoring tasks, and off you go. So if you've ever set up Postgres 9 with its built-in streaming replication, especially in 9.0, it is not this easy. You have to go in and set up a variety of things to get the stuff to work. You have to run some utility to copy the stuff over. If you have multiple table spaces, that all gets more complicated. There's a variety of stuff you have to worry about. Rep Manager just tries to make that abstracted from you. You don't have to worry about it. It just takes care of the whole mess for you, more or less automatically. So the idea is the interface to this thing is mainly command line, as I said. It takes one-line commands and it runs them by default on whatever the node is that you're at. So if you're at node 1, you run something, it's going to run on node 1. You want to run it on node 2 again, just say node 2. This does give you a little bit of a kind of command console kind of feel, because there's this daemon running in the background and it knows how to run things on other nodes. You can sit on one node and actually change the state on other nodes all from one place. So it's kind of neat for doing cluster re-architecture tasks if you've got multiple things that you want to deal with. There is one configuration file that lets you do things like if you have very specific SSH parameters that you need to get rsync to work or other stuff like that. But for the most part, simple installs don't even really have to do too much work on that thing. Failover is when things start to get interesting with replication and with Rep Manager. The simplest case is your master has died and you've got one of the standbys and you want to promote that to be the new master for the cluster. That executes most easily with a command called standby promote. The idea is that you would use the views that Rep Manager provides to figure out which is the most recent of the nodes, which one got the latest copy of the data, and you would pick that one to promote. There is a specific problem that is sometimes included with clusterware tools that is not specifically addressed by Rep Manager that you should be aware of, which is that anytime you've got a cluster set up and one of the nodes has failed, there's this very important thing called fencing. The idea of fencing is that you need to be really sure that the node that has failed does not come back up again. Because if it comes back up and it thinks it's still the master and clients might still be able to connect to it, it can cause all sorts of mayhem for your network. Rep Manager doesn't specifically deal with fencing. The idea is that you would integrate it into some other software that would deal with those sort of problems for you. Typical sort of fencing approaches that people will do are things like, a cheap way is if you've got a power strip that can turn off the power to an individual node, you say, okay, I'm just going to go power that off until an administrator looks at this thing and brings it back up in a controlled way that makes sure it's not the master. This won't let it have power. More complicated ones involve things like turning off the port on the network it's connected to, and in some cases people will use fiber channel switches to just turn off the storage that it's attached to, so even though it's up, it can't actually do anything. So you do still need to worry about that, and that this process actually has one of the most awesome acronyms in computer science. It's the letters for the phrase "shoot the other node in the head." So if you see stoneth and you go, what's that? That's what it implies. It's an important problem in replication stuff that most people don't think about until they discover they've got two masters on the network and all hell is broke loose. Once you've done that, you've promoted one of the standby nodes you had, you need to go to the other standby node and have it now follow that node as its new master. Under most circumstances, if they've both been standbys to the same server, it should be no problem. If you promote the more recent of the two, the other one will then just catch up off of the new master, and there shouldn't even be any complications involved with that. For the most part, this works fine. We haven't actually run into the theoretical situations where it might be a problem. There's a final operation that's a little bit trickier than the rest of them that also gets handled for you by Rep Manager, and it's helpful because it's kind of painful to do otherwise. If you have a standby that's been promoted to the new master, and now the original master comes back up again, that you can't necessarily assume is going to be able to talk to the new master on it. The reason for that is in between when, let's say the thing that screwed the master up was it got disconnected from the network. It might have continued to process a transaction or two after it was disconnected from the network, and those transactions would not be replicated over to the other nodes yet. So what that means is there's now been a divergence of what Postgres calls a timeline. As far as the original master was concerned, it's got a couple of transactions that occurred as the next ones after when it got disconnected. As far as the other nodes are concerned, there are these other transactions that got committed as the next couple after that. You can't really fix that without taking the original master and kind of resynchronizing it completely with the new one. In Postgres, that requires a new base backup for the standby node that you're trying to do this to. So doing that efficiently requires knowing some trivia about the rsync program. rsync has the capability to copy over something that is already a mostly current copy of the database and fairly efficiently only copy over and only write the information that actually has been changed since that original copy was there. So while in theory this could take a long time, in practice it's usually pretty quick because the way Postgres writes things, the way things that are inserted tend to be appended to the end of new files and that sort of thing, it doesn't really take all that long. So even if you've got a terabyte database, which we run this on, rather than the hours or days that it can take to resync a new node from scratch at that size, taking something that already has a copy of the database from an older time and bringing it up to speed is usually significantly faster. Rep Manager D, there is a daemon process that goes along with Rep Manager. When the commands that do registration in it actually set up things so that the daemon can talk to them. This is aimed to both help with monitoring and with management of the nodes. The monitoring thing is actually pretty key. The configuration for it, I mentioned before, it's a pretty simple file. It just looks like this. A couple of name value pairs and what Postgres refers to as a con info string in order to get the whole thing up and running. This is I think, the key thing that Rep Manager provides that Postgres 9 does not, Postgres 9.0 does not. The information about lag, as far as how far behind your standby is in Postgres 9, is in units of transaction IDs. Nobody actually cares about how many transaction IDs you are behind the master. What people want to know is how many bytes am I behind or how many minutes am I behind. You just can't get that information easily unless you do something like what Rep Manager D does, which is save snapshots of transaction ID process at particular times and then line them all up again to figure out, you know, what the actual timestamp involved in this is. So one of the things you get that if you go and build it yourself, you're basically going to duplicate a large chunk of Rep Manager. What Rep Manager just gives you is the stuff that you need to piece together this information. In Postgres 9.1, things get a little bit easier, as I'll say in a second. So what can you use this for? The usual sort of thing that people want is they want to do read scaling. They want to add the standby, and they want to make it useful for actually running queries, not just sitting there idle like standbys used to be before 9.0. In some cases, people don't actually really want to run queries on it. They just want it to be really highly available, and they want to be able to run queries against it to do things like check data quality, make sure everything's up to date, and just gain confidence that that high availability copy really is a useful copy they can fail over to. Another use case, people might want to run really long reports or take data that can be materialized into a view and save that, and then potentially we've done things like build a giant report from the standby and then export that report back over to the master where it can be written to in order to keep from having to compute that data on the master itself. Another possibility is some people use this to scale up by adding multiple read nodes and then splitting small bits of read traffic over. You know, the idea being if you have a web application or something like that that's mostly reads, you can scale that up across a pretty large number of nodes that way. You do need to make sure writes go to the master, and you do need to make sure that that your application is at least a little bit aware of this problem. It helps a lot. You can do it with PGPool 2 as of version 3.0. You can actually put that as a middleware component, a proxy layer in between your database and the application, and it's smart enough to look at the queries for a second and go, okay, does this look like a read query? Does it look like a write query? If it looks like a read query, send it to one of the standbys. If it looks like a write query, it's got to go to the master. So it tries to look at it and figure stuff like that out by parsing it a little bit. It's not necessarily going to be completely automatic for everybody, though. The biggest challenge is if you've got a function call in the database, what some people call stored procedure. If you run that, whether or not it's going to write to the database can require traversing a lot of information, and it's unreasonable to expect a proxy thing will do that. Another possibility, some application servers actually have this concept of I have read and write data and it goes to different places in them. Some people have had success with both the Java enterprise components in JDBC as well as in Django for doing this sort of thing. We've heard some good reports about those. So your application server may already be aware of this concept if it's one of the better ones. So this is what it would actually look like if you were to deploy this with PGPool 2 in the middle. you'd get that kind of routing reads and writes to the correct type of nodes. You'd have all the writes go to the primary, reads could go to some number of read-only nodes, and then every single one of those could potentially become a new master if there was actually a failure. The thing to be aware of, especially in 9.0, is it's hard to tune this situation to run really long reports on, simply because of some limitations of the software. Another possibility is that you add multiple nodes, you optimize one of them to be something that you can fail over to quickly, you optimize the other one to lag behind a little bit more because it's running really long-running reports. You know, all of these are possibilities. You can slice it how you want, and Rep Manager aims to make it a little bit easier to deal with all these cases. There's another possibility, and features like this are getting further integrated into Postgres as of 9.1. In theory, you can take a standby and then make a copy of that standby in real time and send it over to another standby. We use this sort of thing for working on situations like if I'm, you know, I live in Baltimore, if I want to send data to our one office over in the UK, and then I want to get that data over to our other office in Italy, I don't want to have to ship it from Baltimore to both the UK and to Italy. I want to just ship it across the Atlantic once and then let that copy relay over to the other one. So those sort of things are possible with some additional software. The one thing you should be aware of is that doing maintenance, you have to do it all on the master, and that can end up turning into a hard problem. Some examples of things that we run into are when you need to do vacuum, you have to do that on the master, and all of the work that it does has to get duplicated in real time on all of the standby nodes. So even though in theory the standbys are not really getting heavy writes against them, they do have to be powerful enough to keep up with the writes of all this stuff. And unlike some older architecture situations like Sloaney, for example, you can't just take a node and you can't take a standby node and do maintenance operations like vacuum on it to try to clean it. Similarly, if you want to do index maintenance like create index concurrently, that doesn't help either. So there's all kinds of places write bottlenecks can show up at. My most recent fun, I had a system that was set up that was getting beat up with writes and checkpoints were taking 6 hours, you know, all hell breaks loose. There's another issue to be aware of that is kind of inherent to Postgres 9.0, which is that queries can get canceled whenever you're using this architecture. The simplest example, if you drop a table on the master and the standby was running a query against that table, you basically have the choice of, am I going to cancel that query or am I going to keep up with the live traffic? You can't do both. You have to make a decision. Postgres 9.1 actually adds a lot of things that we were doing in Rep Manager into the core database. There is a pgstat replication view that actually gives the data in more human-readable formats. There's a parameter called max standby delay. There's 2 variants of it. It lets you run long-running reports on masters and makes it easier to do that. There's also another feature called hot standby feedback that also makes it easier to run long-running reports on the master. And base backups, I commented that Rep Manager makes base backups easier. It's much easier to do base backups in 9.1 as well. You also get synchronous replication, which I'll talk about in my later talk today, and there's some other little technical details that work. So in some regards, 9.1 makes some of the things that Rep Manager made a lot easier and kind of builds them in. You can use the monitoring stuff that's in 9.1, and you don't need Rep Manager to do monitoring quite as strongly, or at all in a lot of cases, and you don't need it to help with base backups anymore. The trick is there's still some advantages to using it. Being able to execute commands on any node and be able to work on them as kind of a command console thing, that's still helpful. When you do get into failure recovery, the built-in make a base backup stuff that's in Postgres 9, it stops helping you so much. And you end up needing to do clever things like the rsync stuff I mentioned before. Rep Manager knows how to do all those clever things, and you don't have to worry about whether you get the syntax right or not. If you have to figure it out on your own, it's going to take you a while. Rep Manager just gives that to you for free. Also, we're working on Rep Manager 2.0 is in beta right now, and it's got features like automatic failover to just promote the nodes automatically, and you don't have to sit and figure out which one's got the latest data when the master fails. It can help you out with that. One of the things that's good about Rep Manager as well is that it incorporates a lot of information about successful uses of the program that we've got in the field. One of our customers, a fellow named Martin Erickson, has contributed a lot towards the design of this whole thing on a global setup. Heroku is doing a couple of talks here. They're actually using Rep Manager for portions of their Postgres as a service deployment. And the people who are running our 2.0 stuff internally right now are kind of paving the roadmap for this, this automatic failover stuff. And you know, by releasing this out to the world at large and making it free, we're getting lots of interesting bug reports about problems we didn't even see coming, and it's helping to strengthen the software. Rep Manager is open source. It's posted on GitHub. It's been over there since the end of 2010. We are already merging patches from other companies. You know, Heroku did some stuff that we took in. It's aimed to be a community project. We're just kind of steering the whole thing. And so patches are welcome to Rep Manager as well. So I am out of time, and that's what I wanted to cover as well. So I'll take questions, or you can run off. Yep. The biggest database I've had to synchronize up using some of the fancier rsync tools was about 1 terabyte. And I believe it took about a day to sync it up. Unfortunately, that was limited by the network link over the whole thing. So that's not a how fast could you do it if you really had to. But one of the advantages of using rsync as sort of the transport for doing everything in Rep Manager is that rsync has all these neat command line options, like I want to go limit the bandwidth of the network transfer and all these other crazy things. And you know, we find the stuff that's built into Postgres is great for getting the whole thing started, but in the real world, you end up having these situations like, well, now I need to go do this, and I'm in production, and I can't just hog the network for the whole thing, so let's throttle it to this. So that one took about a day, but again, it was limited by the network speed that was running on the whole thing. You could get it done in a couple of hours, you know, in the best case. It really just depends on how fast you can beat on the thing and how fast the underlying drives are. I mean, in theory, we've got servers that could do a gigabyte per second on reads, and those things could, you know, that chews through 1 terabyte in some small number of minutes, but in practice, it ends up being limited by factors that are kind of fuzzy to measure in all cases. But, yep.
Was the tool supporting sort of integration with sound rather than parsing? Doing a SAM volume control?
We've had some people that have been looking into stuff like that. We actually have an extension tool that aims to worry about Linux has LVM snapshot stuff. We've started using that for some things, but that's not been super popular. We haven't gotten too many requests for that. So it's certainly possible to do it, but you know, it took us a while to get all the rsync stuff working correctly for this thing, so it will probably take a while to get any other approach to be equally robust. There's a question back there? Yep. This is basically something to just help improve and make it easier to use streaming replication and hot standby. This is a tool to make those features easier to use and deploy. That's what it uses under the hood to actually do all the replication stuff. Yep. All of the streaming replication stuff that's in Postgres is at the database cluster level. You can't use the built-in replication in Postgres to just copy a single database at this point. That's actually a tough problem to get rid of in general. Yes. The issue is just that the longer the query is running, the odds increase that one of the rows that it's supposed to have visible will get deleted on the master. And if something gets deleted on the master and that comes in there, you're left with the choice of, what do I do? I can either keep up with the data that's come in from the master, or I can delete this row and delete this row, or I can continue to run this query, but you can't do both. You have to make that decision. Yep. Okay. Yeah. I tried to shush people out before while doing questions.